Okay, let's jump right into today's explainer, designed specifically for you 8th grade learners. We're doing something pretty amazing today. We are combining powerful mathematics with some deep real-world wisdom. So, let's get into it.
I want you to imagine something for a second. Let's say you're trying to measure how fast a plant is growing in your backyard, or maybe you're tracking how rapidly the views are ticking up on a brand new video you just posted. If you've ever tracked real-world data like that, you know it is rarely neat and tidy, right? It almost never falls perfectly onto a straight line. So what actually happens when the real world gets messy? How do we make sense of numbers that seem to be scattered all over the place?
Well, here is our roadmap for today to figure that out. We're going to cover 1. Taming messy real-world data. 2. The power of good counsel. 3. Using tech for regression. 4. Some real-world regression examples. 5. Your turn to practice. And finally, 6. Education rooted in morality.
Starting with Section 1, Taming Messy Real-World Data, Finding Order in the Chaos.
You know, modeling messy data isn't just some boring math exercise. It's literally a real-world superpower. In real life, nobody just hands us a perfect equation. Instead, we get a bunch of raw, scattered points. But professionals use a tool called regression to find the order hidden inside that chaos. It's how scientists, financial analysts, and marketers model data, explain trends, and actually forecast what's going to happen in the future.
Let's move to Section 2, the power of good counsel, seeking mathematical guidance.
Now this is where it gets really interesting, because the source material bridges math with spiritual truth. Take a look at this proverb, where there is no guidance, a people falls. But in an abundance of counselors, there is safety. Think about how true that is. When things are completely confusing, you seek out wise counselors, like your parents, teachers, or mentors, to guide you. Mathematics is really no different. When our data is a total mess, we need a mathematical counselor to guide us to the right equation.
And that brings us to our core definition for today. Exponential regression is basically our ultimate mathematical counselor. It's the process of using technology, whether that's a calculator or software, to find the exponential equation that best fits a set of messy data points. Just like a wise mentor guides you to safety, exponential regression guides us to the best fitting function so we can actually understand what's going on.
All right, Section 3, Using Tech for Regression, Tools for the Job.
Before we just start mashing buttons on a calculator, we have to make sure we're using the right tool. Let's compare two patterns. An additive pattern is when values change by adding or subtracting the exact same amount every time. That gives you a linear relationship. But a multiplicative pattern is when values grow or shrink by the same factor. They multiply. And here's the golden rule. If your data is growing or shrinking by a common factor, then exponential regression is absolutely the perfect choice.
Okay, so you've spotted a multiplicative pattern. What's next? Here are 3 simple steps to let your tech do the heavy lifting. Step 1, enter your x and y values into a table on your calculator or spreadsheet. Step 2, select the exponential regression function. Usually it's labeled something like xbreg. And Step 3, just hit enter. The tool will automatically generate your best fit equation, looking like y equals a times b to the power of x. Now, if you are using Desmos, which is an incredibly powerful graphing tool, here is a quick pro tip. After you put your data into the table, you need to type the formula exactly like this. Y subscript 1, then the tilde symbol, then a times b in parentheses to the power of x subscript 1. When you do that, Desmos will instantly calculate and reveal the hidden a and b values. It's practically magic.
Section 4, Real-World Regression Examples, Seeing it in Action.
Let's look at some actual numbers for population growth. At our starting point, where x is 0, the population is 100. At time 1, it hits 150. At time 2, it's 225. And by time 3, we're up to 337.5. You can clearly see we aren't just adding 50 every single time. Going from 150 to 225 is a jump of 75. The population is growing way faster than a straight line. It is multiplying.
So, we feed those raw numbers into our regression tool, and it gives us this beautiful equation. Y equals 100 times 1.5 to the power of x. Let's break that down. The a value is 100, which is our starting population. The b value is 1.5, which is our growth factor. That means the population is growing by 50% every single time period. And the tech figured that out for us in seconds.
Okay, let's flip it and look at a decay example.
This data tracks the amount of medicine left in a patient's system over time. We start at time 0 with 80 milligrams. By hour 1, it drops to 60. By hour 2, it's 45, and by hour 3, it's down to 33.75. It is steadily decreasing, but again, definitely not by a flat additive amount.
We run the exponential regression, and boom, out comes our model. Y equals 80 times 0.75 to the power of x. Our starting amount, A, is 80, but look closely at the B value. It's 0.75. Because B is less than 1, it represents a shrinking factor. The medicine is decaying, leaving exactly 75% of its previous amount every single hour.
Section 5. Your turn to practice. Time for a homework challenge.
I actually highly recommend pausing the explainer right here. Grab your calculator or pull up Desmos and try tackling these 5 homework problems. Use that counselor of exponential regression you just learned. Plug the data in to find the models, think critically about what your A and B values represent, try to imagine a real-world scenario for the numbers, and figure out if it's growth or decay. Go ahead, test out your new superpower.
Finally, Section 6. Education rooted in morality, the ultimate counselor. You are learning some incredibly powerful tools today. Math and science give us the absolute ability to predict, to model, and to understand our physical world. But the foundational philosophy of the Godly Learners series points out something massive. Education without morality will hurt. The idea is that being highly educated without a strong moral compass just equips a person to make more complex, damaging choices. True learning, according to this source, intertwines biblical morality with academic education, ensuring you actually use your knowledge for good.
Because the ultimate goal isn't just to be smart, it's to have peace. Romans 8:6-7 promises peace of mind to everyone who keeps their mind spiritual. The text presents this not as a distant hope, but as the real, lived experience of people who engage deeply with these intertwined truths. Aligning your mind with spiritual wisdom brings a kind of deep, lasting peace that simply memorizing math formulas can never provide on its own.
Which brings us to a massive, final thought to leave you with today. What is the point of being smart and supposedly educated if we just continue to make bad choices that hurt ourselves and the people around us? Seek out the ultimate counselors. Use mathematics to tame messy data and spiritual wisdom to guide your life's choices. If you let your education be rooted in morality, you won't just be smart, you will be truly wise. Thanks for joining us for this explainer, and as always, keep learning.